All right, I'm going to get going. My goal is to stop at 27 to give you the remaining time to formatize the formative. Okay? So that's my goal. Because today, Caitlin, is when we're taking the formative. Okay? Reminding you that next week, Tuesday, is day of the test, and homework is due along with quiz corrections, all that fun stuff. Okay? So let's talk the difference between, we had the law of sines last week, we had the law of cosines this week. Let's talk the difference between the two. Both are great in their own right. Okay? Love them both. We can solve any triangle with them. Okay? Law of cosines can be used on any triangle, but we don't have to because it's a little more intense, if you will, than the law of sines. Law of sines can be used on any triangle, but you got to have certain conditions right from the start. You got to have that complete fraction where you've got a side and its opposite angle. Okay, so if you don't have that, then you can't use that. Okay? Law of cosines is nice because there's always one triangle in a law of cosines case. Okay? There's no ambiguous law of cosines. It's just law of cosines. Oh, excuse me. I had a little yawn there. Okay? Law of sines, got to check for in that angle side case. You got to check for that. Okay? Because inverse sine will never find an angle larger than 90 degrees, we use the law of sines to find small stuff first. We use the law of cosines to find big stuff first. Okay? Because it will give us obtuse angles. Okay? So we always want to find the largest angle first using the law of cosines. Or the side that would then make the triangle or allow us to use law of sines. Okay? With that being said then, here are two warm-up problems. I want you to solve the triangle A equals 1, B equals 4, C equals 8. And I want you to find me the cosine of 105 degrees using the addition or subtraction, sum or difference identity, and using half angle identity. So there's really three warm-up problems here. Okay? Go for it. In the first one, I get no triangle is formed because the sides aren't long enough. Okay. All right. In the second one, or in part A, I get cosine of 105 degrees is the square root of 2 minus the square root of 6 all over 4. And then in part B, I get that the cosine of 105 degrees is negative 1/2 times the square root of the quantity 2 minus the square root of 3. Questions, comments, concerns, clarifications? Seeing, hearing none, let's go on to a word application of law of sines or law of cosines. Okay? So the bases on a baseball diamond are 90 feet apart, and the front edge of the pitcher's rubber is 60.5 feet from the back corner of home plate. Find the distance from the center of the front edge of the pitcher's rubber to the far corner of first base. Then find the angle between the segments connecting the pitcher's rubber to first base and the pitcher's rubber to home plate. Okay? So, start ourselves out with a picture. Come on. Right? Baseball diamond. Just a square tipped on its side. Okay. Then you got the pitcher's rubber right there. What this was saying is that this distance here was how much? What was it saying? Oh, I suppose I got to scroll up. You guys don't have it written down. I thought you guys had it written down in front of you. $60.5 feet. What is this distance here? 90. Okay. First question it's asking is it's asking you to find that pink distance. Second question it's asking you to find is it's asking you to find that angle right there. Okay? How many pieces of the triangle were we given? Only 2, right? How many do we need? We need 3. Okay? We have it. What else do we have? That one down here? Because they're all right angles, right? Because it's a square. So then if I bisect that angle, then this angle down here is in fact 45 degrees. Okay? What kind of a problem is it? LOS, LOC? It's the law of sines? Do we agree with it? It's the law of sines? Because we don't have one complete fraction. Yeah? So it's a law of cosines one, right? Okay? Which then turns into the law of sines afterwards. Okay? So find me those two. Find me the pink side length x. Find me the pink angle. We'll call it P for pitcher's mound. Okay? Find me pink and pink. Go. Agreed? Distance pitcher's mound to first base is 63.717 feet. And the angle that's formed that we're looking for at angle P is 92.824 degrees. Questions, comments, concerns, clarifications? Seeing, hearing none, we will begin then our formative today. You can have out your identities sheet.